This new section takes and expands on what we did yesterday, where we started out section 1, and we're on track. Started out section 1, we talked about ratios. And a couple different ways to write ratios, one of them being a fraction, something like this. And I wouldn't write the 3/4, but so we could do 3/4 like that, we could do 3:4, we could say 3/2/4. So that was section 1, kind of like 3 different ways to do ratios. What are ratios? What do they mean? That kind of stuff. Section 2, then we talked about proportions, was one of the things in section 2, about how proportions are going to be basically one ratio equals another ratio. Fair enough? Now this thing here we want to look at, okay, so if you have a proportion, what happens when you graph that? Can you look at a graph and determine, is it a proportion, is it not a proportion? That's really what we're doing today. So first thing, I'm just going to start with an example. And Mr. Vanderwall, you could write him, you could not write him, but he catches 15 fish an hour. That's going to be our rate. We did rates earlier this chapter too. But Mr. Vanderwall catches 15 fish an hour. So we're going to say how many fish in 1H and 3H. So how many fish does he catch in 1 hour and 3 hours? So in 1 hour he's going to catch how many? 15. So that'd be 15. In 3 hours he's going to catch 45. And to get the 45 you did? Perfect. It's 15 an hour. 3 hours would be 3 times 15. I'm going to take that and try to make it look like what we were doing yesterday. And maybe I shouldn't have done the X and the Y. But yesterday we would take those like rates or ratio type things. And we do like, so in 1 hour he catches 15 fish. In 3 hours he catches 45. So yesterday we were looking at them something like this, right? And it might be worth doing the box. At least I want to get in your head that, are these things here, does this make a proportion? Is 115 equal to 345? Well, one way we said to check it would be to say, well, what would you multiply 1 by to get 3? 3. So you'd multiply it by 3. Then 15 times 3, does that give you the 45? Yep. So then you know that they have that constant multiplier, so those two are going to be equal ratios, or it's a proportion. Proportion is 2 equal ratios. Yes? All right, so right now we have 2 points that make up a proportion. If we were to graph those, and I'm going to try to make my graph look nice. You could kind of do a chintzy job, but I would for sure draw the graph in your notes. But if I were to try to graph those nicely, if you're going to do it, make sure you include the origin. My x values have to go up to 3, so I'm going to put a 1 and a 2 about there and there. My y values have to go up to 45. Well, I'm going to go up to 50. It'll be easier for me to break that up. Then I'd have a 25 right in the middle, like a 5, 10, 15, 20, 30, 35, 40, 45. So, 25. So you don't have to make your graph look as nice. Just don't put your dots on until you see what it's supposed to look like. But my point 115 is going to be right about here-ish. Can I convince you of that if I did a decent job? And 345 is going to be right about here. And that straight line, you notice, goes through my 2 points, and it also goes through the 0, 0, which we often call the origin. So if we have something that's going to be a proportion, the line should go through the origin. So one way to tell from a graph if a line's a proportion is going to be, it'll be a straight line through the points. How do I want to write this? So I'll say a graph of a line through the points of a proportion. Maybe I'll say must go through the origin. So that's one way to tell. That if you were to take and do a graph, draw a line through the points, a nice straight line through the points, that straight line will also go through the origin if it's a proportion. If it doesn't go through the origin, your line through the points, then those points don't make a proportion. Fair enough? And that would work if you had 2 points or if you had 17 points. If those points are all a proportion, if they're all equal, then they'll go through the origin. There's going to be one other way that you can tell. if I were to take these 2 points, and I want to do my y values divided by my x values. So I'm going to scroll down here. And if I were to say for those, y divided by x for each of those. So I had a 15 and a 1. And 15 divided by 1 just gives me 15, right? And if I were to do that for my other point, I had a 3 and a 45. So if I do the y first, 45 divided by 3, 45 divided by 3 equals 15. So we know those 2 points were a proportion. For those 2 points, y divided by x gave us the exact same number. And that's going to be the important thing. So one way to tell if a graph is going to be a proportion is to go through and, look at it, draw it, does the line go through the origin and through the points. The second way, and I'm going to switch to a different color. We'll do red for dramatic emphasis. I'm going to say y divided by x equals k. And k, they use that. K stands for the constant. Great question. Let me quick write this first. Constant of proportionality. Just slide over a little bit. Constant of proportionality. So we had the question, how come they don't use the letter C, which would totally make sense, but a lowercase letter c, they'll type it in italics, but that stands for the speed of light, which it comes from the word celeritas. It's Latin for swiftness.
Capital Celeritas and S.
Capital C and lowercase c look a lot alike? I'm not sure. So I just try to teach the math. They don't let me make up stuff.
They should.
But yeah, math would be so much easier if you just make up the answer. So y over x equals k, and if you have a proportion, you should get the exact same k value for every single one of those points. So that's another way if you want to take and look at your points. So say you have a table like this thing here. You could do, well, 15 divided by 1, 15. 45 divided by 3, 15. If that works for every single x and y value they give you, maybe there'd be more. Then you know you have a proportion. Fair enough? I maybe shouldn't tell you this, but it's in your I can statements. You're going to, on your quiz, on your test, get something like what's on the screen right here. Maybe a graph, maybe a data table, maybe both. But you're going to get a, hey, is this a proportion? Explain why or why not to get full credit. And last year that went really poorly, so I just wanted to kind of throw that at you now. Be ready for something like that, and it'll be listed in your I can statements.
Will
it
the
should
graph
be.
be filled?
Yeah, the graph will be filled in probably if I'm asking you
So
for
we
the
just
graph.
have to graph it?
Well, you could take the points and graph it. If I just gave you the points, I would just do y divided by x and y divided by x, see if they're the same. Or for that same thing, you could do what we did in yesterday's section and say, okay, here I'm multiplying by 3, here I'm multiplying by 3. Same multiplier, and we get. And so then it has to be proportionate to the same multiplier. Is that fair? The other common mistake that I had on the quiz last year was I said to people, find the constant given these data points right here. And what did almost everybody do, you think, that had it wrong? Instead of doing 45 divided by 3, they did 3 divided by 45. Because like a normal fraction, you do this divided by that, right? So just try to program your brain. If I'm asking for that constant of proportionality, if I'm asking for the constant, it has to be like right here. It has to be the y divided by x. You might want to put a big star by it in your notes or an arrow to it. Learn this, or it's not x divided by y. But that's going to come at you. And last year, people weren't prepared for it. Okay for me to quick move on? So I'll do the last part kind of quickly. And just kind of want to show, like, well, what does it look like if it's not a proportion? So I'm going to say down here, lines. So lines not through 0, 0. And I'm going to finish my statement there later. So I'm going to leave myself kind of like a blank line underneath that. But if I were to take points that aren't a proportion, and I have a graph, so if I were to have a couple points and my line doesn't go through my origin, so say I have something like that with these 2 points, I wouldn't worry about the numbers. I'm going to try to make numbers that work nicely just so you guys can kind of see what happens. Looks like I kind of missed a little bit, but 0, 1, so that'd be like a 4. I'll put that point over a little bit further. 1, 2, 3, 4. Okay, so maybe then I'd have something like the point 1, 4. So I'd have like a, I don't know, 1, 2 is going to be 1 point, and, or 1 over 2. So if you had the point 1, 2, it'd be like this in an XY table, right? And my other point looks like it's 4, and my aim was off, so I'll maybe say 3.5. So that would be 4 over 3.5. I thought it looked like 3.5, but something along those lines. So we could check and see, well, is that, so for the graph we're going to find out it's not a proportion, because if I were to take my 2, maybe take my 1. To get from my 1 to my 4, I'd have to multiply by 4. So if it's a proportion, I'd have to do the same thing in the denominator, and 2 times 4 is 8. It's not 3.5. It's nowhere close to 3.5. So one way to check, they have a different multiplier, so we know it's not a proportion. The other way to check it would be to say, well, is it x divided by y or y divided by x? Nice. If you're getting that constant, it has to be y divided by x. I'm going to throw that at you one more time. So if we have 2 over 1, my constant here is going to be a 2. But if I were to take that other point, my constant there is going to be 3.5 divided by 4, which is like 7 over 8, so 0.875. So you get different k values for those two different points. So different k values tell you it's not a proportion. Is that fair? So final thing, what in the world did I want to say, and then we're done. Lines not through 0, 0 do not represent proportions. So lines not through 0, 0 do not represent proportions. So if I gave you a graph and said, hey, is this a proportion? You could just look and see, does a line through those 2 points, does that go through the origin or does it not? You could answer it that way. Or you could get points out of the graph like I did here and then test it either this way or by finding your k values. Feel like you know enough to be dangerous?
Yeah, I'm
Awesome.
dangerous.